In this video, I will show you how to build the standard form equation of a hyperbola given the vertices and the asymptotes. This should be fun. For number 8, we're given vertices and we're given the equations of the asymptotes. And understand this is really two separate equations. We have y equals 3x, that's one asymptote, and y equals negative 3x. Alright, that's what the plus or minus means. Let's graph what we got and see what we can do with it. So the vertices are at 1, 0 and negative 1, 0. So that tells me that I have vertices here and here. Now, the asymptotes. These asymptotes pass through the origin, 0, 0. In my mind, I guess I'm thinking about y equals mx plus b. So y equals 3x. 3 is obviously the slope. The y-intercept b is 0. That's why there's nothing here. So this is a line that goes through 0, and then it has a slope of 3. Or you could think of it as 3 over 1 if you wanted to talk about the rise and the run. So I'm going to draw this. So it's starting at 0. Alright, this is the center. And it has a rise over run of 3 over 1. So if I go up 3 over 1, that's going to be a point on the asymptote. If I went up 3 over 1 again, that would be another one. So the asymptote, well, the asymptote with a positive slope anyway, is doing like this. I could continue it in the other direction by going down 3 and left 1, and then down 3 and left 1. Okay, so again, this asymptote is doing something like this. The other asymptote is also passing through 0, but it's down 3 right 1. The negative 3 over 1 means that it is down 3 and right 1. Okay, so if I wanted to draw that asymptote, down 3 right 1, it would be like this. Then down 3 right 1 again. So the negative sloping asymptote is going like this. And if I wanted to continue this side, I'd have to go up 3 left 1 just to continue the pattern. Alright, so I have drawn the information that I have, the vertices and the asymptotes. But, okay, so right now, there's a lot of the equation that I could write. Because the reality is I could actually draw the hyperbola right now. If these are the vertices, and so these branches have to start at the vertices and approach these asymptotes. So I know I'm dealing with a hyperbola that looks like this. Okay, I know that's not the best drawing in the world, but this is a horizontal hyperbola. Because it's horizontal, I know I'm going to start with the x term first, and the y term will go second. Also, the center is 0, 0, which tells me I will simply have x squared and y squared, nothing being added or subtracted. So all I need is my a squared and my b squared. Well, guess what? I also know the a value, because the a value is the distance from the center to a vertex. So this yellow right here is my a value. In other words, a is equal to 1, which means that a squared is actually also equal to 1. So this is just going to be 1. So all that's missing is my b squared. So how am I going to find that? They did not give me the foci this time, so I can't find the c squared and then subtract. I have to do something else. Well, what I need to do is realize that the asymptotes are the diagonals of a rectangle that contain the co-vertices and the vertices. So imagine trying to draw a rectangle that included, the sides of the rectangle have to pass through the vertices. So I'm going to draw a rectangle, but it has to hit these vertices. So I know that my rectangle is going to go like this. Okay, here's my rectangle. Okay, the rectangle passes through the vertices. So these are sides of my rectangle. Okay, but I also know that the asymptotes have to pass right through the corners of this rectangle, which means right here where the side of my rectangle hits the asymptote, this has to be the corner, and this has to be the corner. Right here where the side of my rectangle hits the asymptote, corner and a corner, which means that this must be the other side of that rectangle right here. So because of that, I now know what the B value is. Hey, check it out. The B value is going to be the distance from the center to a co-vertex, which is clearly right here. Alright, the other side of the rectangle. So I know that my B value is 3, which means that B squared is 9, which tells me that this other denominator must be 9. It's like magic. That's it. That's the answer right there. Now I just got to remember what I wrote down. It was x squared over 1 minus y squared over 9 equals 1. Okay, that's it. Hopefully number 9 is similar, because I feel like we need practice on this type. Yay, number 9 is the same type of problem. Let's practice this again. We have vertices at 0, -4, and 0, 4. So I have a vertex here, and I have a vertex here. What else do we know? The asymptotes are y equals 2x and y equals -2x. Again, understand this is really two separate equations. Y equals 2x and y equals -2x. That's what the plus or minus means. And the slope of 2 really is like 2 over 1 and -2 over 1. The y-intercept here is 0. It's like y equals mx plus nothing. So these asymptotes pass through the origin, and this one has a slope of 2. So let's draw that. So look, the center is at 0, 0. The line y equals 2x is going to start at 0, but it's going to go up 2 over 1. Okay, so up 2 over 1, up 2 over 1, and so on. So I've got this asymptote doing like this right here. I'm going to continue the pattern this way by going down to left 1. So that would be like this, and like this, and like this. Okay, the other asymptote is down to right 1. Okay, so down to right 1, down to right 1, down to right 1. So this is the downward sloping asymptote. I can continue the pattern by going up to left 1, up to left 1, up to left 1, up to left 1. Okay, so the asymptote. So now I've drawn my two asymptotes. So look, right now I could draw the hyperbola. Alright, this is a vertex. I know that the hyperbola has to approach the asymptotes. So here's one branch doing like that, and here's another branch doing like this. So this is a vertical hyperbola, which tells me that the y term has to be first because it's vertical. Also, because the center is 0, 0, right in the middle, this will simply be y squared and x squared, not y minus 3 squared or anything like that. So all I need is my a squared and my b squared. Well, we're in luck with the a squared. A squared is just going to be the distance from the center. Did I say a squared? The a value will be the distance from the center to a vertex. So in other words, a is equal to 4. So therefore, a squared is equal to 16. So that means this will be 16. So all I need now is b squared. I don't have the co-vertices, which is where I normally get the b from. So instead, I'm going to have to use the fact that the diagonals, the asymptotes should pass through the diagonals of a rectangle. A rectangle that also passes through the vertices and the co-vertices. So let me say that again. I need to draw a rectangle, and two sides of the rectangle will pass through these vertices. So that means I'm going to have a side of a rectangle right here, and I'm going to have a side of a rectangle right here. Okay, now I am stopping at the asymptotes when I get there. Alright, I'm stopping right here because the asymptotes also pass through the diagonals of this rectangle. In other words, right here where the side of the rectangle touches the asymptote, this should be a corner of the rectangle. Okay, which means that the other sides of the rectangle must be here and here. Now that I can see where the other two sides of my rectangle are, I can tell you exactly where what the b value is. Okay, so the b value is the distance from the center to the co-vertex, which is right here. So that means that my b value is 2, which means that b squared is 4, so this is 4. So this is the answer right here. Okay, that's it. Standard form equation of the hyperbola with these vertices and these asymptotes. This video is way too long, but I just have one more problem to do. I've got this equation. I'm trying to write it in standard form. I know it's a hyperbola because I have these two squared. One of them's positive, one of them's negative. To make it standard form, I need a 1 over here. So I clearly need to divide both sides by 160. Okay, it's 160. So I just need to reduce these fractions. 16 goes into 160 10 times. So this is going to be y squared over 10. Let's see. How many times does 9 go into 160? It does not go in evenly. Slow down. Okay, this is going to be a little bit ugly, but I don't see any way around it. What I can do is take this fraction 9 over 160 and sort of do a little reciprocal deal with it and make it 160 over 9. I'm trying to force this into the denominator, and you know that if I do x squared over 160 over 9. Well, how do you divide by a fraction? Don't you multiply by the reciprocal? So you know that this is the same thing as x squared times 9 over 160, right? All right, you multiply by the reciprocal. And wouldn't this be the same thing as 9x squared over 160? So working backwards, 9x squared over 160 is the same thing as x squared divided by this fraction, 160 over 9. Okay, so put that little trick in your back pocket in case you need it again one day. Okay, if you ever get a fraction and it can't be reduced, you can just sort of do the reciprocal, drag that 9 underneath, and then now you got this handy dandy little fraction. Why, Burton? You ask. Why? Well, we'll talk about that later. First of all, we know that the center is going to be 0, 0, because I've just got y squared and x squared right now. So the center is still 0, 0. There's no x plus 3 or something like that. So did they even ask me for the center? No. So fine, never mind. In fact, I should be making a sketch. Alright, now I need to find my vertices. The first denominator, the denominator of the positive term, is the one that we call a squared. So that means a is going to be the square root of 10. For graphing purposes, I need a decimal approximation. So let's see, the square root of 10, that's approximately 3.2. So this 10 is with the y term, which means I will do my 3.2 plus or minus 3.2 in the y direction. To the sketch. Okay, 1 to 3.2 in the y direction. 1 to 3.2. So these are my vertices. Okay, and this really is radical 10 and negative radical 10, just in case I need that later. What else? How about those co-vertices, people? Yeah. So my co-vertices, well, this is b squared right here. So if that's b squared, then b is going to equal the square root of 160 over 9. Okay, great. What I really need is the decimal approximation for this right now anyway. So what's that? Turns out that's approximately 4.2. Okay, this is going to be in the x direction because this is the x term. So I'm going to go about 4.2 in the x direction. So 1, 2, 3, 4.2 would be about here. 1, 2, 3, 4.2 would be about here. Okay. What am I finding? I'm losing track of what I'm supposed to do. I'm supposed to identify the vertices, the co-vertices, the foci, and stuff. Okay, so I guess I will finish sketching this hyperbola. So I've got my vertices and now my co-vertices. Okay, I feel like I need to simplify this now. Now that I'm labeling things, I have my 4.2, but this simplifies. I've got the square root of 160 over the square root of 9. That's how you take the square root of a fraction. This is 16 times 10, so this would be 4 radical 10. And of course the square root of 9 is 3. So this is really my b value, is 4 radical 10 over 3. So I'm going to put that in my diagram now. Okay, this is really 4 radical 10 over 3, and negative 4 radical 10 over 3. So great. Now I've got my vertices and my co-vertices. I feel like I should go ahead and record that information. So this is 0 comma radical 10. So here come my vertices, you guys. Alright, those are my vertices. And then my co-vertices are negative 4 radical 10 over 3, comma 0. And of course, positive 4 radical 10 over 3, comma 0. So I've got my vertices and I've got my co-vertices. So now I need my foci and my asymptotes. Okay, I feel like I shall go ahead and draw the rectangle. So there's a rectangle that goes through the vertices and co-vertices like this. I need this rectangle so I can draw the asymptotes. Okay, the asymptotes go through diagonally like this. Okay, this is a rough problem, man. This problem is so ugly. It makes me just fear that I'm making a mistake, because I rarely see a problem this ugly. Alright, so here's my hyperbola approaching these asymptotes and stuff. Okay, so I guess I'll find the foci now. So I should have foci floating in the interior of these branches somewhere. So the way I can find the foci is by thinking about the c value. I know that c squared is equal to a squared plus b squared. So c squared is going to equal, okay, a squared is 10 and b squared is 160 over 9. So that's going to be 10 plus 160 over 9. Okay, I'm going to need like denominators here, so I'm going to have to multiply by 9. So this is going to give me c squared is equal to 90 over 9 plus 160 over 9. So this is going to be 250 over 9. So that's c squared. But I need the c value. So that means that c is going to equal the square root of all this. So I'm going to do the square root of 250 over the square root of 9. I'm taking the square root of both. Obviously this is 25 times 10. So when I take the square root, it will be 5 radical 10. And the square root of 9 is 3. So this is my c value. Okay, a decimal approximation for this. This is approximately 5.3. That's just for graphing purposes. Okay, so let's see. 1, 2, 3, 4. 5.3 would be about here. Okay, 1, 2, 3, 4. Okay, so these are my foci. Okay, but I have to use this value for the exact. So for example, this focus right here would be 0 comma negative 5 radical 10 over 3, for example. Alright, so of course the other one would be 0 comma positive 5 radical 10 over 3. Ugliest problem I've ever seen. Okay, how about these asymptotes, man? I'm going to have to go back and cut this video in half because it's twice as long as I want my videos to be. Maybe this one problem will be a whole video by the time I edit. Anyway, the asymptotes. When you have a line going through the origin like this, the equation is actually pretty simple because it's going to be like y equals mx. Okay, you know, y equals mx plus b, but the y-intercept is just 0, so you can forget about the b. So all I need to do is worry about the slope. That's it. So what's the rise and run? Well, guess what? This is the rise, and this is the run. Okay? Because if you look at the corner of this box, the corner of the rectangle that we drew for the asymptote, hopefully you can see that we had to go up. Okay, this amount. This is the rise, which is radical 10. And then we have to go over this amount. Okay, so our rise is the radical 10, and the run is the 4 radical 10 over 3. So, what am I going to do with that? So I've got y equals. So my slope is radical 10 over 4 radical 10 over 3. Okay, obviously I have to simplify this garbage, alright, but all of this right here, this is my slope. So when you divide with fractions, you multiply by the reciprocal. So I'm going to do radical 10 times, okay, and I'm multiplying by the reciprocal. So this will be 3 over 4 radical 10. Okay, so this radical 10 is in the numerator. Now I have a radical 10 in the denominator. So that's great. I can definitely cancel out these radical 10s. Oh, really? Really? You know what? I'm going to keep talking. So that radical 10 went away. All I have left is 3/4. So the slope is really just 3/4. Can you believe that nonsense? Hardest problem I've ever seen, and the program crashes. So I'm just going to grab that information. I believe we had decided that we had y equals 4 over 3x, and because we had the two asymptotes, one positive, one negative, we'll just put a plus or minus on that thing. And that is it. Alright, that is a crazy, crazy problem. I fear that I made a mistake somewhere because it was just so ugly that I just can't even believe it. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.